Hello, Ray. This is Nick Totiro, Professor of Information Technologies and Computer Science, Lakeland Community College. How do we get IP addresses, right? On a network, most, if not all networks now are TCP/IP. 30 years ago, we had a wide variety of different networking schemes. Novell had IPX, SPX, Microsoft had NetBEUI and NetBEUI. Slowly but surely, quickly because of the internet, we went over to TCP/IP, and now most networks, if not all networks, are TCP/IP. If you took the Networking Plus with me, you should have learned that generally speaking, there's two ways to get information or get something, specifically getting an IP address. You could manually get something where you physically turn on the computer, you go to a particular setting, and you change that setting. Let's say we're changing TCP/IP, we're giving an IP address, right? If I was a network engineer, I would go to 100 machines, and at each machine, I would sit down. I would put the IP address, the subnet mask, any pertinent information, and then when I was done with that machine, I would go on to the next machine. If I had to do that many, many years ago, if I had to do that, that could be an all-day event. Along comes a protocol called DHCP, Dynamic Host Configuration Protocol. And what that does is it automates the assignment of IP addresses. Excuse me. Now what we do, we don't even care about the IP addresses on our computer. We basically turn on our computer and we know our computer is going to get an IP address from somewhere, right? How does all that work? Well, there's a lot of little things going on. And again, if you took Networking Plus with me, we go into a little bit of detail. But basically what happens is when you turn on your computer for the first time, if your computer does not have an IP address, it will broadcast to its segment of the network. Remember from Networking Plus, broadcasting is a necessary evil. We don't like broadcasting on networks because it generates a traffic, but sometimes we have to use it. DHCP relies upon broadcasting. So you turn on your computer, it doesn't have an IP address. It then goes out and says, hey, I don't have an IP address. Is there a DHCP server that will hand off an IP address? Now, because it relies upon broadcasting, we have one of two ways that we can implement this. We could have the DHCP server on the same network segment. Then that's real easy. The DHCP server on that network segment will say, yeah, I have a DHCP server. I'll give you an IP address. Here you go. The other way we can do it is we don't want a DHCP server on every single segment. We could have many, many segments of our network. We could have what are called DHCP relay agents. See, inside a router separates two separate networks. Inside a router, routers do not like forwarding broadcasting. So if I'm on one side of the network and I broadcast, it doesn't go over to the other side of the network. But we could install on the router what's called a DHCP relay agent. Or we could actually do it on another server, but basically we would do it on the router. And what that does is when your computer boots up and it says, I need an IP address, the router says, oh, you need an IP address, I will get it for you. Then the router or the relay agent, more specifically the relay agent, will go to the DHCP server directly, wherever that may be on the organization's network, gets an IP address, hands it back to the client. Now, a lot of things, because we don't like broadcasting, there's a lot of things that we do to reduce broadcasting. First of all, this is not a DHCP course, but one of the ways that we reduce broadcasting is every time your computer boots up does not mean it looks for an IP address. There's something called a DHCP lease, right? And what the lease does is says you can use this IP address for X amount of time, right? You don't have to turn on and reboot every time. And there's other functionalities that are associated with this. So we just generally reduce the amount of broadcasting. But the very, very first time you turn on a computer that's on a new network, yeah, it has to go through a broadcast. If it's already had an IP address, it's already been on the network, good chance it's not going to rely upon broadcasting. Now, that's important in the forensics world because we could potentially be looking at two different logs here. We could be looking at a log that is generated by a network device like a Zeek device or something that's basically listening for traffic. Or we can go directly to the DHCP and say, "Can you show me your logs?" Right? Let's go up to our Zeek site and let's take a look at just what the traffic would look like on our particular network. Alrighty, there's not much here, right? But I do want to show it so you understand what's going on in the network. At 4 o'clock in the morning, a computer basically booted up and its IP address was 0.0.0. You will notice here it's using port 80. So it's broadcasting or it's going out. That's what, it's not really broadcasting. This traffic here is the computer booting up. It's relying upon broadcasting. Anytime you see 255, 255, 255, 255, that just means it's a broadcast. It's using port 68 and 67. That is, sometimes they call that the bootstrap port. Now they just call it the DHCP port. Remember, ports and things like that. And it says this particular device here that doesn't have an IP address is broadcasting, it needs an IP address. This is the MAC address that's associated with the requesting device. This here is the DHCP server address. It's the reply. It is the DHCP server saying, "Oh, you're new to the network. Here is an IP address." Now on the DHCP side, there's a bunch of other things going on. It's recording. It won't release the same IP address twice. So there's going to be log files and stuff like that at the DHCP server. And it's just basically saying, here is your IP address. You received that from port 68, which is that bootstrap or that DHCP port. That's what's going on. Now, this particular log file was generated by a network device that's listening to the traffic. There would be a log file on the DHCP server side, right? DNS has its own log file. Web servers have their own log file. Clients have their own log files. On the DHCP side, what we would see in there is a very rudimentary log file. I don't have a copy of one. Very rudimentary log file that basically would say this IP address was handed off to this MAC address. And then we can trace back the particular MAC address. So this particular log file just gives us who or what machine access code is getting what IP address. So just another log file that we have on our network. Like I said, most network forensics has to deal with investigating log files. You may be looking at several different log files to kind of figure out what's going on. Let's say, for example, you're looking at an IP address, but you're not aware of who got that IP address. Well, you can look at the DHCP records and say, okay, it's going to this machine access code address. Well, I don't know whose machine that is. Maybe that was somebody who put on a rogue device or something. So there's a lot of investigation that's associated with log files. And DHCP is just another piece inside that puzzle, right? That being said, obviously, let's go learn something.